Alright guys, so this is the last video of chapter 8. This is for section 8.5, and here we're talking about recursive series, okay, or rules. So recursive, and all that really means is that we use the previous term or terms to find the next. Okay, so we have to use what we have before to do that. So in order to do that, we're always going to be given what our first term is because we have to use that to go on. Okay, we can't just give a rule. We have to use our first term. All right, so if I look at example 1, it says write the first 4 terms of each sequence. Now, a sub n minus 1, this is referring to the previous term. Okay, so we know a sub 0 is 1, that's given. And a lot of these will start at a sub 0, not all of them, but some of them will start at a sub 0, some of them will start at a sub 1, like over here. Okay, so a sub 1 would be a to the 1 minus 1, which is 0, plus 4. We'll notice our a plus, or our a sub 0, guys, is 1, so this is 1 plus 4, which is equal to 5. Okay. Now, a sub 2 is going to equal a to the 2 minus 1, or just 1. How about I just write 1? 2 minus 1 is 1, plus 4. Now, a sub 1, guys, is 5, so this is just 5 plus 4 is 9. Okay, here's our first term, second term, third term. A sub 3 is a sub 3 minus 1, which is just a sub 2, plus 4. And a sub 2 is 9, which is just 13. Okay, so the first 4 terms would be 1, 5, 9, and 13. So 1, 5, 9, 13, so on and so forth. Okay, so do that. Try to do B on your own. Now this is written a little bit different, but it's the same concept. You know, f of 1 would be a sub 1. Okay, so try to find, we're given f of 1 is 1, so find f of 2, find f of 3, and find f of 4. That would be the first 4 terms. So go ahead and try that on your own, and then we'll go over it. All right, on part B, you should have gotten 1, 3, 9, 27, and then it just keeps going. Okay, so here's all the steps worked out if you didn't get that, to kind of try to see where you went wrong. All right, now we can write both arithmetic and geometric sequences as recursive sequences as well. Okay, so where when we write an arithmetic sequence, it's just a sub n equals the previous term. Remember, a sub n minus 1 is the previous term, plus our common difference. Okay, so it looks a little different, but it's going to be the same thing. And then our geometric series sequence is going to be r times our previous sequence, where r is the common ratio. Okay, so we're going to multiply the previous by a certain number over and over and over. All right, so let's look at example 2. Okay, so here we have plus 10. Here we have plus 10. Plus 10, plus 10. Okay, so we can immediately see that this is an arithmetic sequence. Okay, we're adding the same thing to both sides. Now to make it a recursive sequence, which is what we want, so a to the n is going to equal, and I'm just going to pull straight from this, it's going to be our previous term plus 10. Okay, but remember, in order to do our previous rule plus 10, we have to write what our previous rule is. Okay, so if we can say a, and we're going to put a sub 0 if you want, a sub 0 equals 3, and then we could say a to the n equals a to the n minus 1 plus 10. Okay, that just tells me, hey, I'm starting at 3, and after that it's 3 plus 10, and then it's 13 plus 10, and then it's 23 plus 10, so on and so forth. All right, so if I look at part B, I notice that 16 to 40, I'm multiplying by 1.5. 40 to 100, I'm multiplying by 1.5. multiplying by 1.5, and multiplying by 1.5. Okay, so here I have a geometric series with my R value as 1.5. Okay, so to find my rule, I would have to state my first term, so I'd say a sub 0 equals 16, and then every term after that is 1.5 times my previous term. Okay, so these two together would be my rule for part B. All right, let's look at example 3 now. Okay, so example 3 is a little bit more difficult because these are neither geometric nor arithmetic sequences. So we're just going to have to use our smarts and use our brain to figure out our pattern here. Okay, now some recursive rules we can be given more than the first term. Sometimes we can be given the first 2 terms or the first 4 terms or the first 8 terms. Okay, I don't see that happening, but you can. Okay, so if I look at a pattern here, well, 1 repeats itself. Then I add 1 to get 2. Then I add 2 to get 3. Or sorry, 1 more to get 3. Then I add 2 to get 5. Okay, so that's kind of confusing. Okay, but if I notice, 2 is just 1 plus 1. Okay, 3 is 1 plus 2. 5 is 2 plus 3. So to get 5, I'm adding the 2 terms before. Okay, to get 3, I'm adding the 2 terms before. Okay, and to get 2, I'm adding the first 2 terms. Okay, so I'm going to let my a sub 0 equal 1, and I'm going to let my a sub 1 equals 1, 2. I'm going to tell whoever I need to, hey, the first 2 terms of the sequence is 1 and 1 and 1. Okay, after that, I can say my next terms are always the a to the n minus 1 plus, this is the previous term, and the previous 2 terms would be a to the n minus 2. Okay, so in words, I'm just adding the 2 previous terms. Okay, so when I add the 2 previous terms, I'm adding, this is the first previous term, this is the second previous term. All right, let's look at B now. All right, I have 1 here, 1, 2, 6, 24. So I immediately see 1 times 2 is 2, 2 times 3 is 6, 2 times 3 is 6, 6 times 4 is 24. Okay, so I'm going to write that. This is 1 times 1. This is 2 times 1. This is 3 times 2. This is 6 times 4. Okay, so if I let this be a sub 0, this be a sub 1, this is a sub 2, a sub 3, and this is a sub 4. Okay, so notice a sub 4, I have 4 here. A sub 3, I have 3 here. A sub 2, I have 2 here. A sub 1, I have 1 here. So what I'm doing in words is I'm going to say each term is in times, so it's the term times. I'm going to multiply in times the previous term. Okay, so this here, I'm 1 times this one. Okay, this is my first term, so it's 1 times this gives me 1. Okay, my second term, I'm multiplying 2 times my previous term, which is 2. My third term, I'm saying 3 times my previous term, which is 6. My fourth term, I'm saying 4 times my previous term, which is 24. Okay, so to write that here, I could say a sub 0 equals 1, and then I could write a sub n equals, it's going to be n times my previous term, which is a sub n minus 1. All right, guys, so because this is so new, I highly, highly, highly encourage you to do the monitoring progress on the next couple slides. Okay, so go ahead and try these on your own. There's 1, 2 here, 3, 4, 5. There's 5 of them. So go ahead and try those. See what you get. See where you're having problems with. See if you've mastered it, and then we'll go over them. All right, so here's what I got on the first set of monitoring progress. All right, here's what you should have gotten on the top part. Okay, and if I scroll down, here's what you should have gotten on the bottom.